Alright, we're going to finish this last one here. It's just showing you how trapezoids can be drawn very differently, but we still can calculate our parts. This is base 1, base 2, and that would just have to be your height. Look at it that way. See how much easier it is to see where your height and your bases are? We just have to plug it in. Area equals the sum of our bases times the height all over 2. So 200 plus 350 times 180 all over 2. And so we get 550 times 180 divided by 2. And you should get a very large number with this. And you should get something like 49,500 square meters. Kind of large, but it works. Okay, end of trapezoids right now. Just don't forget to use special right triangles in our Pythagorean theorem. Now, here's the cool thing. The next one is rhombuses and kites. And please understand, rhombuses and kites have two things in common. They're quadrilaterals, and they have perpendicular diagonals. So one thing you do is like how you mark up these diagrams. I know a rhombus, I always do this. All the sides congruent, perpendicular diagonals. On a kite, I mark my pairs of congruent sides. But the cool thing is we use the same area formula for both. Now, I know a rhombus is a parallelogram, so I can use those properties. And a kite isn't a parallelogram, so I use other properties. So I understand it can be treated very differently, but the cool thing is it comes down to the exact same formulas will help me solve for them. Now, a rhombus can be also used area equals base times height, but we don't have to do that if there's a faster way. The formula that works, and this works for any one because of the perpendicular diagonals, so any quadrilateral with perpendicular diagonals, this formula would work, and it's the following: diagonal 1 times diagonal 2 all over 2. Now, let me rewrite that because it looks horrible there. Diagonal 1 times diagonal 2 over 2. Now, some people go 1/2 diagonal 1 times diagonal 2, and that's fine if you have fractions. But here's the thing you need to remember. I need the whole diagonal. I need the whole length of that diagonal. The whole diagonal. I need the length of this whole diagonal, not just part of it. So let's go ahead and use that to calculate our kites. Now, when I tell you it's a kite, I would totally quickly mark what I know, because when I have kites, we're also going to be looking for the angles, and it's been such a long time since the beginning of the school year. I mean, it's been like 3 weeks. We have to make sure we remember these. So let's do the first one. Area equals diagonal 1 times diagonal 2 over 2. So what are my lengths? Well, I have to get the whole thing. 8 plus 8 is 16. Then we have 11 plus 9. Well, that's 20 all over 2. And that would get me 160 square centimeters. Does everyone see how I got that? Okay, I hope it's because you realize I just added them all together to get there. Now, I'm doing the exact same thing over here. I get area equals diagonal 1 times diagonal 2 all over 2. And diagonal 1 here end up being 9. Diagonal 2, I have to add everything together, and it's 12 all over 2. And I get 54 square feet. So there's our area. So it's not too bad. But now notice with rhombuses, we're going to have to apply the properties of a rhombus as well as using our area formula. So we're going to go with it right here. And here I have a rhombus, so the first thing I always mark are the congruent sides, and then the second thing I always mark is my perpendicular diagonals. After that, the rest of it kind of comes easily. So I know my formula is going to be used right now because we just got it, diagonal 1 times diagonal 2 over 2. Now looking at this, I only have 9 and 5. Now, are those the length of the whole diagonals? Problem is, that's no, it's a portion of it. So what can help me get that length? What are some properties of a parallelogram that help me get that length? And someone, I remember class went, said they bisect each other. That's right. The diagonals bisect each other because it's a parallelogram. So that means I can really just double them. Because I know this one will be congruent to that one. I know these two will be congruent to each other. So that would be 5, and that would be 9. So now when I plug it in, it's really easy to get. 9 plus 9 is 18. 5 plus 5 is 10, all over 2. That's going to end up being 90 square meters. Not hard to do, but I had to use a property of a parallelogram. Now, let's look at the next one. This one's kind of sneaky, but don't let it fool you. Once again, I know it's a rhombus, so I know all the sides are congruent. They didn't give me anything with the angles, so I can't assume I can do it like we did the other day, but I do know that the diagonals are perpendicular to each other. Now, just like the last problem said, I know the diagonals are going to bisect each other, so I right away know that those two have to be the same. These two have to be the same. So when I'm plugging it into my formula, I at least have one of my diagonals, because this would be 12, would be 24. Well, what's my other one going to be? There has to be something that can help us figure this out. Well, I look at this, and maybe the right triangle can help me. And someone goes, it's a 30, 60, 90 triangle. Now let me ask you this question. Where's the 30? Where's the 60? I don't think so. But I also know from my previous page with review, if I know two sides of a right triangle, I can use the Pythagorean Theorem. Now, I could sit there and calculate the Pythagorean Theorem, or I can pray and double check that it's a triple. Well, look at this one. Blank, 12, 15. I hope you said, oh, that's a 9, 12, 15, triple. That's right. And the cool thing is that I automatically know the other segment, so it's 18. So when I do that, I get 12. I go 24 divided by 2 first. 12 times 18. It's going to be 216 square meters. Now that's not hard to do, but if you forgot, you were going to have to like call this segment x and go x squared plus 12 squared equals 15 squared, and it's a lot easier just to have it memorized as a triple. Now, unfortunately, the next diagram is very hard to read, and so I just want to redraw it just a little bit so you can see what it's trying to illustrate. Right here, and they tell you this segment's 3 centimeters, and right here that angle is 45. It's still a rhombus, so I know those are still the same. I still know they're perpendicular, and hopefully I know that they're still going to be bisecting each other. Now, one thing you need to remember is this is going to end up being a 45, 45, 90. So what do you know about the legs? The legs of a 45, 45, 90 are the same. Well, that means all of these are going to end up being the same size. They're all 3 centimeters. So when I do my area formula, diagonal 1 times diagonal 2 over 2, it's really easy to plug and chug. 3 plus 3, not 3 times 3, remember it's 3 plus 3, 6 times 6 over 2, which is going to give you 36 over 2, which is 18 square centimeters. Now there's a lot of other ones with radicals and 30, 60, 90, but don't forget to try these. I know this takes some time. Don't forget you can stop, pause, rewind them, and use those to your advantage. All right, guys, have a good weekend.